All right, so this question here, the questions are very similar to the ones we just had on number 1, number 2, number 3, or number 2 and number 3, right? They're very similar. The only difference is they give the given part, right? On, let's go back here. The first question, they gave you velocity, right? And they ask you displacement, moving left, moving right, stopped, total distance, right? That was the first one. And then the second one was similar, just different context. It was sand in, sand out, sand already there, but we told how much will totally be removed, how much will total number of sand there at a certain time, right? And then the last one was, oops, skipped it. Total amount of sand. When was the minimum total amount of sand? Okay. The last question goes kind of back, it's kind of a combination of the two. It goes back to velocity. They give us a graph. Okay. They say the graph represents Karen's rides her bike along a straight road from home to school, starting at time 0 minutes. And she arrives to school at time t equals 12 minutes. During the time interval from 0 to 12 and everything in between, her velocity in miles per minute is modeled by the piecewise linear function whose graph is shown to the right. And this is a calculated question. Okay. So her velocity is tracked there. Okay. We're going to get to this in a second, but what's one thing that stands out? Is there anything that stands out in the graph? I'm just focused on the graph right now. What's a couple things about the graph that we should note before we go on? Yeah, it's a negative down here. Yeah, that's one thing they're going to address in the question, but it's good to kind of formulate an idea right now before we even start. When do we have negative velocity? When do we have negative velocity? When is there negative velocity? What causes it, or when do we have it? What causes a negative velocity, and when do we have it, and what does it note? What is it? It's a girl riding her bike to school. So why would it be negative there? What are some scenarios where it could be negative? What causes a negative velocity? Negative velocity, right? Velocity equals 0. Positive velocity. When does one switch from one to the other? What happens? What happens? When does one switch from one to the other? What happens? In terms of someone riding their bike. Yours? Exactly. They change direction, right? They go from one direction to the other direction. That means, right? In order to do that, you have to stop first, right? So she's riding her bike and then she stops and goes in a different direction. Okay. Now, does that mean she just turns right? No, that doesn't. She's not turning right. She's not turning anywhere. It means she's going in the opposite direction in which she came. Okay. And we'll get to that part in the question. But it's always important to kind of have that idea before you start the problem of what you're looking for. Why? What causes that? What causes that here? Okay. Okay. So let's go back. Oops. Let's go back to, why is it this? There we go. Let's go back to the, let's go start with A. Find the acceleration of Karen's bicycle when t equals 7.5. When t equals 7.5, what's her acceleration? Okay. How do we find acceleration? What are we going to do? We're going to use the graph because that's the only piece of information they've given us. What do we do to find acceleration of, for anywhere, for anything? What are we going to do? Mm-hmm. Yeah, exactly. They've given us velocity. Velocity is the antiderivative of acceleration and vice versa. The acceleration is the antiderivative of um, of our acceleration is the derivative of velocity. Okay, so we're finding the derivative. That's pretty much what we're doing, finding a derivative. Let's see, derivative of v of t at t equals 7. How do we do that? That's exactly what we're going to do. We're going to find the derivative of the graph at 7.5. So how do we do that? How do I find derivative of a graph? Mm-hmm. Exactly. Derivative means slope. Derivative means slope. Now I only have a graph, so I have to go rise over run. So 7.5 right here. So that means right there is 7.5. Well, that dot is part of a segment. It said it's a piecewise function. Piecewise function means it's a bunch of functions put together, a bunch of linear functions put together. Right here, piecewise linear function. This one is a bunch of lines put together. Okay. This is a line right here. Then this is a line right here. This is a line, that's a line, that's a line. The one we're looking at is right here. So we have to find the slope of that line. Okay, so slope. We go down 1, over 1, down 1, over 1. So slope equals, so when we go down, we're not going down a whole unit though. We're going down a tenth of a unit. Okay, so we go down 0.1 units over 1. Since we can use a calculator, you can do that in your head. Actually, it's over 1, so it's just going to be the same thing. It's going to be negative 0.1. What unit of measure? What unit of measure is that going to be? It's going to be a rate, so it's going to be per something. So yeah, we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like miles. Yep, miles per minute right there. Okay. You always get a point. If they indicate, you should always put unit of measure, even if they don't ask. You should always put unit of measure if there is a clear unit of measure, because that might be worth a point. And again, a point here, a point there, that could be the difference between AB, CB on the test. So you should always look for those little things. Those little things add up. Okay. All right. So same question or same Not same question, same prompt, same background. Nothing's changed up here. Graph's still the same, words are still the same. Using correct units. Explain the meaning of this. So, in context, in other words, with units. They're asking us to find, in words, what does that mean? And then also do that, figure that out. Okay, so in context, I want you to take, I'm going to give you about a minute. Words first. Don't worry about calculating. We'll do calculations next. What does that mean? What does that mean? Okay, so this setup looks familiar. Not necessarily the 0 to 12, but the absolute value bars. I've seen those before. And I've seen the absolute value bars around V of t. I've seen that before. Where can I find that? Where was it located? Where have we seen it before? We've seen it a couple times. Where would you originally see it? In the table at the beginning, right? In the table at the very, very, very beginning, we saw it. Right there. Distance traveled, right? Total distance traveled. How far has she gone over the course of 0 to 12 minutes, right? So that's what we're going to write. We're going to go back to that one here and say, so you can put this in you don't have to say the exact same words I'm using, but essentially you have to say the same thing. Essentially, if yours says the same thing, then you're good. So this is what I put. The total distance, right? Because that's an integral. Anytime it's an integral, it's going to be a total. The total distance Karen traveled over the 12-minute period. Okay. Right? Anytime we're doing an integral, it's total. We know this is distance because we looked on our table from 0 to 12. Okay. How do I calculate this? Can't use my calculator because I don't have anything to put in my calculator, right? They've already given me the graph, so I can't use the calculator. So how do I figure out what that number is? How do I figure out what that number is? How do I figure out how to calculate this? Mm-hmm. Where all the values where? On the graph, right? Because that's what that means, right? It's V of t, but it's got absolute value bars. So that means everywhere V of t has to be positive. Okay. So where is it not positive? We just talked about that, right? It's not positive there. So where are these values going to be if they're positive? Where are these values going to be? If they're not negative, we know they're going to be positive. Where are they going to be? What do you know about absolute value? Where are they going to be? It's going to be on top of the graph. Yeah, where on top of the graph? Is it going to be like here? Where? Like I know it's going to be here, but where exactly? Like there's a dot here, for example. There's a dot here. 3 negative 0.2. Where is that dot going to be? It's going to reflect. Yeah, it's going to reflect across the x-axis because it has the same value, just not negative anymore. Right? So it's going to be that. Okay, so I'm not considering this right now. Okay, good. How do we do it then? I still haven't figured out how to calculate my answer because I got to get a number here. How do I do that? Mhm. Area under the curve, yep. Anytime we're doing an integral, area under the curve. Okay, so you got two triangles. Both look like they're the same size. They both have bases of 2. They both have heights of 0.2. Okay. And then you have this guy over here. I would break this up into smaller pieces. If you want to, you can break it up any way you want to. But be careful. Each square is not a whole unit. Each square is not a whole unit. Okay. So be careful when you're doing that, because the easy way is just to count boxes and say those are whole units. No, they're not whole units. Okay. So I would break it up into smaller pieces. Okay. So when you break it up into smaller pieces, each of these guys right here, each of these is 0.2. Base times height divided by 2. This guy right here has a height of 0.3, but a width or a base of 1. So 1 times 0.3 is 0.3 divided by 2 is 0.15. Okay. Then I would probably break it up into this guy here, rectangle. 1 by 0.3 is 0.3. And then the next one is a trapezoid. Trapezoid is base 1 plus base 2. Add them together. So we get 0.2 plus 0.3 is 0.5. 0.5 times the height, which is 1. Half of that, which is 0.25. Then we have the rectangle here. That's base is 3, height is 2, 3 times 2 is 6. 0.6, sorry. And then the last one is a triangle. Base is 1, height is 0.2. 0.2 divided by 2 is 0.1. So you're going to have 0.2 plus 0.2 plus 0.15 plus 0.3 plus 0.25 plus 0.6 plus 0.1. When you add those all together, you get 1.8 miles, because it's total distance traveled. It's not a rate, it's just a total. Okay. Part C talks about exactly what we just talked about earlier, what we talked about at the very beginning. We talked about the very beginning. It's something you should always do, look at things in the graph, but especially because they asked you on point C. So I want you to read point C, think about what we're going to do. You know how to do it. We've actually done questions like this before. Okay? So look at point C. I want you to answer it. I'm going to give you a few minutes to answer it. Read it, answer it. We've talked, this is actually not a new question. It's an older question that we've talked about before. Okay? Give a reason for your answer, justify your answer. Okay, so I want you to do that one on your own. We'll talk about it in a minute or two. Okay, so how do we know when she goes back home? How do we know, when does she go back home? I should say, when does she go back home? At what time from 0 to 12 does she go back home? And how do we know? So that's what creates this guy here. right? So the question says, when does she turn around? So when exactly does she turn around? When t equals 2. And how do we know she turns around at 2? Because velocity changes from what to what? Changes signs from positive to negative. Boom. Yeah, that has nothing to do with this chapter. That's a review question that we've talked about before. When velocity changes signs, that means change in direction. Okay? Okay, so here we go. Now, here's more of the type of question. Question 4 is the type of question you would see on a FRQ. Okay, same prompt, but now they're asking you to compare two things. They're giving you a graph. So they'll always give you a graph or a table, right? Graph is the same thing as a table, but when people see tables, they get freaked out. It's the same thing, right? A table is the same thing as a graph. You just make dots, and instead of, they just didn't draw the picture, but it's the same thing, okay? Same thing. So Larry also rides his bike along a straight road from home to school in 12 minutes. His velocity is given by the function w of t. Okay, so now they don't give us a graph for his, but they say here, that's um, that's his velocity, that's his rate. Okay, where w of t is in miles per minute, who lives closer to the school, Karen or Larry? Okay, and then show the work that leads to your answer. Well, how do we know? What's going to tell us who lives closer to the school? What's going to tell us who lives closer to the school? How are we going to know? Like, what do we need in order to tell who lives closer to the school, Karen or Larry? Don't think about calculus. I'm not thinking about calculus here. I'm just thinking about what's going to tell you if you live closer to the school. Like me and Mr. Yates. How do we figure out, like if we're talking, how do we know who lives closer to the school? What's going to tell us that who lives closer to Central? How far you travel, right? He lives in Kerman, so he doesn't live that far. He's about 2 miles down the road. Okay. Me, on the other hand, I don't live too far away, but I live in Fresno. I live in town. So he's like, I got 2 miles. And I'm saying, I got 5, 6, 7, 8, 9, whatever miles I have. So he lives closer, right? Miles, right? That's what we need to figure out. We need to figure out total miles traveled, right? If we can figure out total miles traveled for Karen and for Larry, then we can say compare, right? That's how we compare. So we need total miles. Oops. Or traveled, I should say, for Karen and Larry. If I had that, I could answer the question right now. Okay, that's what I need, right? A lot of times that makes sense, right? That makes sense. If you and a person, you want to know who lives farther from the school, you just miles traveled, right? That's common sense. But I'll tell you what, if I give this question to students, they get stuck on step 1. They don't even know what they're doing. And I'm like, no, just figure out what you're doing in common sense. What are you doing? Once you do that, you start to see buzzwords. Ooh, total miles traveled. Wait, I've seen that before. Once you get that going, then your brain starts going from there, right? But this is the hardest part. Probably the easiest part is noting what are you doing? Okay? Okay, so don't we already have one? Don't I already have a total miles traveled for Karen or Larry? Wasn't one of the questions that? Go back and look at one of the questions. Did one of the questions say total miles traveled for one of them? Or total distance, I should say, right? Well, why is that number not correct? Yeah, she went back, right? She started on her trip, and after 2 minutes, she's like, I forgot something. So she went back and then went to on her way to school, right? So that little bit there, we don't count. We're not going to count on our way, stop, forgot a book, go back. Where are we going to start counting for her trip? Where are we going to start counting for her trip? Roman? There you go. Actually, yeah, 5 minutes. Yeah, we can do 5 minutes. Yep. I was going to say four, but it doesn't really matter, 4 or 5, because they're both the same distance, right? We're going to start right here when she actually goes somewhere, right? Because here, let me use the other one. The other one's not marked on. So for Karen, she's on her trip, but then she forgets something, changes direction. Okay, now I can start on my trip. So it doesn't really matter where you start, 4 or 5, because the distance from here, there's no area there. So you're not going to add anything. So like Roman said, start at 5. So this is where I need to find area under the curve for Karen. I did that. I just need to add the numbers. 1.5 or 0.15 plus 0.3 plus 0.25 plus 6 plus 1. That'll tell me how far she traveled. So I'm going to put Karen. I'm going to put the numbers that I added, 0.15 plus 0.3, because they want the work that leads to your answer. This is part of the work that leads to the answer. Or you can mark up the graph too if you want. You can mark up this graph, something that tells them this is how you did it. 1.4 miles. You can mark up this graph and say, cut it up the way we did before, or you can just put these numbers there. Something that leads them to say, okay, that's how they did it. That's what they want to know. They don't want to guess on how you did it. Okay. So Karen traveled 1.4 miles to get from home to school. Larry, how do I find out? How do I use Larry? Larry didn't give me a graph for Larry, but how do I find Larry's total distance? What am I going to do for Larry's total distance traveled or total miles traveled? How do I figure out Larry? Hmm? Exactly. Finding if we're going to set up an integral from 0 to 12. It didn't say Larry went backwards anywhere. So it doesn't really matter if you use absolute value or regular for W of t, because you should get the same answer. That's all the work I need to see. It's a calculator question, so you don't need to do antiderivative. You use the calculator. So go to the calculator and figure out how far he traveled. Okay, so if you want to integrate math, if you forget later on, that's why I'm recording this. So you can, I did this before in last week, one of last week's lessons. So you can also look at that one too. 0 to 12. We can't put W of t because the calculator doesn't know what W of t is. But what we can use is the actual function they give you. So pi divided by 15. I put those in parentheses because those are separate from the sign. And then I'm going to put sine. And then in parentheses, it's pi. It's going to be pi t or pi x over 15. So I'm going to put parentheses in there. Pi x, close the parentheses, divide, and then the numerator is 12. And make sure all my parentheses are closed. Looks like they are. Nope, I need one more parentheses. Insert. So if you open a parentheses, you got to close it. So they gave me one to start out with. I have one at the end. These two parentheses close out pi over 15. Then I have one, they gave me one for sine, and I had one, I think I have an extra one, don't I? Let's see, that's for sine. That's for, yeah, I have an extra one. Let me delete that one. Yep, okay. Enter. If you get some sort of error, it's probably because of parenthesis related. Okay, or if you get an answer that's different than the answer I'm getting, it's always parentheses related. Okay, add more parentheses or make sure your parentheses are closed. Okay, so 1.6 miles is Larry. So who lives closer to school? Karen. Lives closer to school. Because she traveled 1.4, Larry traveled 1.6. All right. So I'm going to give you some problems on your own now. I want you to try. I want you to do number one. I only want you to do number one right now. Don't worry about the rest. We'll save the rest for tomorrow. It says homework on there, but it's not due anytime. I'm going to give you a few days to do this. But I want you to work on number one right now. It's got a couple parts to it. Okay. So number one. Okay. Number one.